Hey everyone, and welcome. Today, we're diving into one of the most fundamental and frankly, most powerful ideas in all of programming, functions. Think of them as your secret weapon for turning code that feels messy and complicated into something that's clean, organized, and just works beautifully. You know the feeling, right? You start a project, it's all simple and straightforward, but then it just grows. And before you know it, you're staring at this giant, scrolling wall of text that's a total headache to manage, let alone debug. Well, what if I told you there's a much, much better way to handle that? So here's what we've got on tap today. We're going to start with the problem, when code gets complicated. Then we'll introduce our hero, the function. We'll see a direct tale of two programs to really see the difference, break down the 4 key benefits, and even expand our toolbox a bit. And finally, we'll see how this all leads us from total chaos to crystal clarity. All right, first up, let's talk about that moment every programmer hits. You're adding features, things are getting more complex, and the sheer number of lines of code just keeps piling up. It's a classic growing pain. To make this totally real, let's picture a company that makes these cool custom tents. They're shaped like a cylinder with a cone on top. And their big challenge is they need a program that can spit out an accurate price for any customer's design, and fast. So think about what this program has to do. First, it's got to take in the tent's dimensions. Then it needs to figure out the canvas area for both the cylinder part and the cone part. After that, it has to calculate the cost of all that canvas. And finally, it tacks on an 18% tax to get the final price. That's a handful of separate jobs, for sure. And without a plan, this is what you get. All of those different tasks, getting the input, the area math, the cost, the tax, they just get smushed together into one long, single block of code. A monolithic program. Sure, it might work, but wow, is it hard to follow. This right here is the chaos we're talking about. Okay, so how do we fix this mess? How do we bring order to the chaos? Well, the strategy is built on one simple, incredibly powerful idea: functions. The big picture strategy is called modular programming, and it's exactly what it sounds like. Instead of writing one giant program, you break it down into smaller, independent modules or blocks. Each block has one specific job to do, which makes the whole thing so much easier to build, understand, and fix. And the tool we use for that? It's the function. At the end of the day, a function is just a named chunk of code that does one thing. You can write a little recipe, say, for calculating tax, give it a name like calculate_tax, and then you can call on that recipe anytime you need it from anywhere in your program. Now for the fun part. Let's see this in action. This is where it all clicks. We're going to look at that tent pricing program written in 2 totally different ways. I mean, just look at the difference. On the left, you've got the beast, that one long monolithic script. But on the right, it's so clean. The main part of the program is short and easy to read. It's like a manager just telling specialized functions what to do. You calculate the cylinder area, you do the cone area, and you figure out the tax. And you know, the source material just hits the nail on the head here. It says it is evident that Program 72 looks more organized and easier to read. Yeah, no kidding. You can instantly understand the program's logic without getting bogged down in the nitty-gritty math. But making your code easier to read is just scratching the surface. Functions give us like 4 major superpowers as programmers. Let's break them down. So first, obviously, there's readability. Then, and this is a big one, functions reduce code length. You write the code once and you can use it 1,000 times. That leads right into reusability. You can take a really useful function and just drop it into a completely different project. And finally, and this is huge, it eases teamwork. One developer can work on the area function while another tackles the tax function, and it all just plugs together perfectly. And believe it or not, the power of functions doesn't even stop there. Once you really get this basic idea, a whole universe of possibilities opens right up. See, functions get really flexible when they can accept data, which we call arguments, and give back a result, which we call a return value. That tax function isn't very useful if you can't tell it the price, right? So you pass the price in as an argument, it does its magic, and then it hands the final number back out. This input, process, output dance makes them incredibly powerful. And this concept of reusability leads to something amazing. You don't have to write every single function yourself. Python, for example, comes with a giant toolbox called the standard library. It's packed with pre-built functions, all organized into these packages called modules. Need to do some tricky math? Generate random numbers? There's a module for that. And using them could not be easier. You just have to tell your program which toolbox you want to open. You do that with one little command, import. So if you need all the standard math tools, you just type import math. Simple as that. Once it's imported, you can use any of its functions just by pointing to it. You use the module's name, then a dot, then the function's name. So, to get the square root of 144, we just ask the math module to use its sqrt function, like this, math.sqrt144. And bam! Just like that, the function does its job and hands you back the result, 12.0. That simple little sequence, import, use, result, saves you from having to write a whole complex algorithm for finding square roots yourself. It is the ultimate example of not reinventing the wheel. So let's bring this all home. We started out in a state of chaos, right? Where our programs were getting longer, messier, and just plain unmanageable. And we found our solution. Functions are the absolute key to modular programming. They let us take a big, scary, complex problem and just slice it up into a bunch of simple, bite-sized, and reusable little pieces. They're the building blocks that bring structure and, ultimately, clarity to everything we build. And that really leaves us with one final thought. This idea, this approach of breaking things down, it isn't just for code. It's a really powerful way to solve almost any complex problem. So think about it. What's a big, messy challenge in your own work or even your life that you could make clearer just by breaking it down into smaller, more manageable functions?